This is the first section of chapter 2 on measures of location and spread, and this section is on measures of central tendency. So what is a measure of central tendency? Well, it's a number or a single number we can use to represent what is going on in the center of our data, in our set of data, in our data set. So we've got three measures of central tendency. They are the mode or the modal value. So this is the most frequent value or the most frequent class with the highest frequency. The median, so this is the value that's in the center when the data is ordered, when it's put in order, normally from smallest to largest. And then the mean, and the way that we work out the mean is the sum of all the data items divided by the number of data values. So the sum of the data values divided by the number of data values here. And we use this symbol here to represent the mean, and we say X bar. Now, if our data is in groups, then we would use this X bar equals the sum of Fx over the sum of F, where F is going to be the frequency of each of our classes, and X is going to be the midpoint of each of our classes. Example 1. The mean of a sample of 25 observations is 6.4. The mean of a second sample of 30 observations is 7.2. Calculate the mean of all 55 observations. Okay, so this is the formula we're going to be using. So let's look at the sample of 25 observations. So if we do that working, it says that the mean was 6.4 and it was a sample of 25 observations. So the number of observations was 25 and we want to find the sum of the data. So the sum of the data for those 25 observations will be equal to 6.4 times by 25. That gives us 160. We want to do the same for the second sample. That had a mean of 7.2. This time there were 30 observations. Now what was the sum of that data? So the sum of that data is going to be 72 times by 30, or 7.2 times by 30, and that gives us 216. So now we can work out the mean of all 55 observations, because we know the total for all 55 observations, and that was 160 plus 216 divided by the 55 observations will give us the mean of all 55 observations. So that's going to be 376 divided by 55. So work that out, and pressing the SD button we get 6.8363 up top. Now we will round our answers to three significant figures. That's what's expected. So 6.84, and we'll write down three significant figures. Example 2. Rebecca recalls the shirt collar size X of the male students in a year group. The results are shown in the table. Find for this data, part A, the mode. Okay, so we want to find the data item that comes up the most. So that is 16.4, that comes up 34 times. So our mode is 16.5. Part B, we want to find the median, so we want to find the middle data item. So we need to know how many data items there are. So number of items, data items, or the number of measurements, 3 plus 17 plus 29 plus 34 plus 12. So that gives us 95. So 95 data items. To find the position of the median, we need to take the number of data items, add 1 to that value, divide by 2 to find the position of the median. So that's 96 divided by 2, so 48. So the 48th value is the position of the middle value. So now we're going to use cumulative frequency to find out where the 48th value is. Well, the first 3 values are 15s. The next 17 values are 15.5s. So that takes us up to the 20th value. The next column takes us up to the 49th value. So just keep it running total. The next column takes us up to the 83rd value. And then that takes us all the way up to the 95th value. So I want to go across until I get to the 48th value. Now I'm going to find the 48th value in this group here. That's where I'll find the 48th value. So that means that the 48th value is 16. So 48th value is 16. So that is my median. So let's write that down. Median equals 16. And then part C, we want to find the mean. Seeing as this is a frequency table, the mean is the sum of the frequency times the data divided by the sum of the frequencies. Right, so this will be the data, so that's 15 times by 3 plus 15.5 times 17 plus 16 times 29 plus 16.5 times 34 plus 17 times 12. That's all got to be divided by the number of data items, the sum of the frequencies, which we've worked out already. Worked out here. That's 95. Okay, so now we'll work out what the top is. We'll do this calculation. So don't just write down the answer. Always work out what this top part is, and that will give you 1,537.5. We're going to divide that by 95. Now that gives me 16.1842. I want to round that to 3 significant figures, so I'll give it as 16.2 as the median for the collar size, so 3 significant figures. Now part D, explain why a shirt manufacturer might use the mode when planning production numbers. Well, when planning production, they're interested in the size that they need to make most of, and that's going to be the mode. Okay, so here's that worded down here. So you should now be able to do exercise 2A on pages 22 to 23 of the textbook. Example 3. The length x millimeters to the nearest millimeter of a random sample of pine cones is measured. The data is shown in the table. Part A, we want to write down what is the modal class. So the modal class is going to be the class to group with the highest frequency. So there's the highest frequency. So the modal class is 34 to 36. Part B, we want to estimate the mean. Now the reason we're estimating the mean is we're having to use the midpoint to calculate the mean. We don't know what all of these 2 values were. We don't know what these 25 values are here. So since we're using the midpoint, our mean is going to be an estimate. So this is the formula we're going to be using, where x is the midpoint of each of our classes there. So let's do our working down here, because it's going to take a bit of space. So to find a midpoint, we can add these 2 together, or the class boundaries together, and divide by 2. So x bar, my estimate for the mean, will be the first midpoint, which is at 30.5. So I'll have 2 times by 30.5 plus 25 times by 32.5 plus 30 times by, and now this midpoint is different, so be careful. You might be tempted to write 34.5, but the midpoint's actually going to be 35. The midpoints are different. And then for the last group, the midpoint is going to be 38. So 13 times by 38. And all of that needs to be divided by the sum of the frequencies, which is going to be 2 plus 25 plus 30 plus 13. So using our calculators, what we get at the top of the fraction is 2417.5. What we get at the bottom of the fraction is 70. So if we do that division, we get 967 over 28, which is 34.5357. And we're going to round that to 3 significant figures. So we'll give our answer as 34.5. That's 3 significant figures. Okay, we'll just move on to part C. In part C, what we want to do is to find the median class. So first thing we need to do is to work out the number of data items, which is the total frequency. So number of items. We've worked out the total frequency already, that's 70. Then we want to find the position of the median. Position of median. Well, that's going to be 70 plus 1 divided by 2. And that's 35.5. So the 35.5th number is the middle data item. We want to work out where that is. We use cumulative frequency. So there's the first 2 data items. The next 25 take us up to the 27th data item. The next 30 take us up to the 57th data item. Next 13 take us up to the 70th data item. So we want to go across until we get to the 35th value, and that is going to be in this group here, because this goes basically from the 28th value to the 57th value. So our median class is 34 to 36. Let's just highlight answers before we move on. So there's the median class. Here's our estimate for the mean. And here's our modal class. So you should now be able to do exercise 2B on pages 24 to 25 of the textbook.